We're going to take a look at how to scale down the size of the universe to make a scale model. We're going to use a 1 to 10 billion scale model. And let's see how that turns out for us. So the table to the right gives size and distance data for the planets at a certain point in time. Notice that the diameter and the distance of planets actually changes throughout the year and throughout the decades. So this is just one version of this table that you might see. So calculate the scaled size and distance for each planet, and we're going to scale it down to 1/10 billion of its normal size. A couple caveats here. That means that we're actually going to shrink our planet diameters down to the millimeter, okay? And then we're going to shrink our distances down to meters. Now, if we do that based on Mercury, let's take a look at how that turns out. Remember that we're using a 1 to 10 billion scale. So I'm going to use Microsoft Excel to do this. So I go ahead and I take the table and I'm going to type it into Microsoft Excel. And then I'm going to convert the diameters from the table, which are in kilometers, into meters. Now we're actually going to convert them into millimeters. So then I'm going to multiply by another 1,000 to convert them into millimeters. But again, we're going to scale this down. We're going to scale it down, but we're going to give ourselves 1/10 billionth. So that means I'm going to take the diameter and divide it by 10 billion. And that gives us actually just a 0.5 millimeter diameter for the size of Mercury. And that's why we scaled it down so much, right? Mercury is only going to be 0.5 millimeter. So this scale is going to be pretty small. Let's look at the distance. If we take the distance and do the same thing, we're going to round it down. We're going to put distance in meters because we scaled down 1/10 billionth. If we're using that 1/10 billion scale model and we take the distance of Mercury is 50.8 million kilometers from the sun. Now let's turn that million kilometers into kilometers simply by multiplying it by 1,000,000. And then we're going to convert it to meters because a kilometer is 1,000 meters. So we're going to multiply by 1,000. And now we're going to scale it down to fit our model. We're going to divide it by 10 billion. And that gives us a much more reasonable 5.1 meters. Now, you might notice that as we get bigger, you'll notice that Neptune is 454 meters. So the scale of the universe is monstrous. The size of the universe is not something that we can really comprehend with that scale model because it shrinking even down to 1/10 billionth. We've now made the planet so small, but they're still sometimes hundreds of meters apart.